And then there's the confirmation line, so the believers find the information and confirms the belief. Now most of these you can turn around and say the same about the skeptics, climate change skeptics. So why is it useful to know about this cognitive bias as well? First of all, as Ruth said, we can change people's mental models, and if we know the things that affect the way they form an opinion about the world and about climate change, we can actually improve the communication. So knowing about these cognitive biases of both skeptics and believers will help us communicate climate change. And so stepping away from the biases, we're coming just back to the heuristics, or knowing what the psychologists tell us is happening, the shortcuts that we take in our thinking processes. Why is that useful to know about those? Well, as Rashid said, economics can help develop incentives to change our behaviour. So if we actually know something about the mental shortcuts that we take about our behaviour, it actually helps develop these incentives at work. So we can overcome some of the unintended consequences that happen when we develop incentives without looking at what happens in people's heads when they make decisions. And as Aline said right at the start, we need these couple models that couple the human to the biophysical environment. So we need as much realistic information as we can get to build these models. Now I get to my qualitative modelling. This was the introduction to it, but I just wanted to build that around you, that economics is not only concerned with decisions about money, but actually can take some psychology into consideration. So qualitative modelling is one of the number of approaches that, as I said before, that you can use to couple the human to the biophysical system. It's not data hungry, so it's not like looking at Ecosim or Ecopath, where you need a lot of data to even start. It's intuitively very simple. In fact, when I present it might look too simple to you, but it's actually a very powerful way of looking at the system. It can follow really easily from conceptual modelling, and on Monday you did your conceptual models, which basically means your idea of how the world sort of works together. And it can be developed. It doesn't need to be just scientists that do it. You can actually build a qualitative model with people in the community, with children, or with anyone, with teenagers, or whoever you want to incorporate, because it's not difficult at all. So those are the strengths. So just to give you an introduction, now I'm going to be sort of diverging completely away from the behavioural economic stuff. Qualitative modelling was developed by a gentleman called Richard Evans, who was a mathematician still alive, and basically they were based on sine graphs that you can see here. And there was a few historical things that had to happen before qualitative modelling came about. So we started in the 12th century with a gentleman by Fibonacci, and some of you might have heard of him. He basically developed the exponential or geometric increase in populations. Basically what it said in his book is he put a couple of rabbits in a box, and obviously a male and a female, and then he watched what happened over a series of, over time, and obviously there was an exponential increase in the number of rabbits that ended up in the box, which is the exponential growth population density curve here. So 5 centuries later, along comes Malthus, and again, most of you would have heard about Malthus. He took that population, the geometric increase in the population curve, and said, well, food or resources don't increase, they increase very exponentially. So look, we've got a problem. And we're still going back to this graph now to say that we have got a problem. Very simple concept from the 1700s. Then skip another couple of centuries, and along come Logic and Volterra, the two. Obviously, we've talked about them just about every day in this summer school. They took the Darwinian evolution of population densities and created these two first order formulas here. Basically, what Richard Evans did, this is the guy that developed qualitative modelling, he took that mathematical relationship and said, okay, what we've got here is what's called a community matrix, and it shows exactly the same as that, and so does the sine diagram. So basically, the shows you that predators have a negative effect on prey, and the prey has a positive effect on predators. This is individual 1 and individual 2. This here shows you the same thing, and I'll show you that a bit more, how we use our notation in qualitative modelling. So qualitative course. Qualitative modelling basically, something like that is a positive effect. So if it's an arrow, it's a positive effect. If it's got a dot at the end, it's a negative effect. So here we have the sign for a predator-prey relationship. One has a negative effect on the other, and the other has a positive effect on the other. This is competition, and these are two lizards from Cuba. I can't remember the names, but one is introduced and one is native, and the introduced one is competing with the native species. So there we have the competition. Here we have mutualisms, where both organisms, the anemone and the clownfish, have a positive effect on each other. They help each other, so two arrows. Amensalism, which is basically one has a negative effect on the other, but the other has no effect on it. So there we have penicillin and staphylococcus. So penicillin has a negative effect on the cell. Here we have what's called commensalism, which is the cow has a positive effect on the bird, but the bird has no effect on the cow. Or the other way around, I'm not sure. And then we have what's called a self-effect, and that can be either positive or negative. But with the self-effect, think of it like population density, basically. If you get too many animals in an area, then eventually they'll have an effect on itself, a negative effect on itself. So just by these simple graphs, you can describe any relationship that can occur. So we'll just go from 2 variables to 3 variables now. We've got a fishery that catches large fish that eats small fish. That's all that says. So we can translate it into a community matrix again. So on the vertical, on the diagonal here, we've got what's called a self-effect. So the effect of small fish on small fish, large fish on large fish, etc. Here we can, for instance, this shows the same as this shows the signs only. So the interaction of the large fish on the small fish is negative. The interaction of the small fish on the large fish that eat them is positive, and the interaction of large fish on the fishery is obviously positive because they catch it. So everyone's following, right? It's very simple principles. So I'm just going to tell you first what they can do, and then I'm going to show you 3 examples of qualitative models, 2 of which have incorporated human behaviour in it. So what you can do with these qualitative models when they've got obviously more than 3 variables in it is that you can identify key drivers in the systems. You can imagine if there's lots of feedbacks and relationships between the different variables, that it gets really complex to figure out if you perturb one, what will happen to another one that's also being affected in this way and that way and that way. So using qualitative model and the mathematics that lies behind it, which I won't go into, can tell you what might happen, what the key drivers of change are. So there's 2 terms that qualitative modelers use. You can have what's called a press perturbation, which is basically a shift in the parameters that lead to a new equilibrium, or you can have a pulse perturbation where you basically give the population a shock and see what happens to everything else. So another thing that qualitative models can do, they can assess the stability of the system that you thought. So if you think of a positive feedback system, if you describe the system and you have a positive feedback system, it can get out of control because the positive is positive. So if you have a negative feedback system, it will go back to equilibrium, and there was a couple of talks this week that talked about that. So from a qualitative model, you can quite quickly figure out whether you've missed something and you've got a positive feedback system that makes the system unstable. So qualitative modelling can be really nicely used to identify data gaps, because if you're drawing up this model, you can figure out, okay, I'm missing something here, and you can use that for further investigation as well. And so the additional benefit of qualitative model that I've sort of already mentioned is that it's really easy to produce with stakeholders. You know those relationships that I've shown before. Everyone intuitively can do those. So I'll just show you an example, and it's one of those things where you're looking at somebody else's spaghetti diagram. So I'm going to go through it slowly, so hopefully it will make sense. what we did in an Australian case study is we built a qualitative model that basically connected the climate drivers, so the things that are happening due to climate change, or the drivers that are causing that change, to the marine environment, to the users of the marine environment or the marine sectors. So what we did is we built with an group of experts, so we had about 20 experts from all the fields in the room, and we built this qualitative model, and then we went to the communities and also built a qualitative model with people in the communities, and we could tell some interesting things from just doing those things. So here I'm showing you the temperature drivers, and we've talked about all of those in the different models this week. Temperature is changing, the current systems are changing, rainfall patterns are changing, sea level rise, wind, etc. So I'm showing you here the marine environment grouped into different group variables. So that's what you have to do. You can do it by species, but we wanted to represent the whole environment. So I've got this thing here called retained species, which is basically the fish that we keep, that we eat or sell. And then we have the things that we throw back that we might catch but we don't do anything with. And then we have what I think called emergent species, which are species that are coming into area through either range shift or other ways. And then we have these other two things there as well. So there's relationships between those. So if you look at the temperature one, temperature here is assumed to have a negative effect on retained species. It has a positive effect on emergent species, so new things that are coming into the area, and I'll let you read the rest of them. So then we put in the marine sectors, and obviously when you are developing these qualitative models, people have to actually talk about why they think that's negative. So you actually, in the process of building it, you get a whole lot of information about why people think that's a negative thing. So that information you can use actually in your interpretation as well. So there's links between the marine groups and the marine sectors. So, for instance, the retained species, so the things we sell and eat, has a positive effect on commercial fishing. It has a positive effect on the shark sector. Again, this speaks for itself. So the things that we don't eat, that we throw back, they don't have a positive effect on the commercial sector because they're not interested in those. Whereas they do have a positive effect on recreational fishing because they get pleasure out of just catching them. So this is the start of the qualitative model, but it doesn't stop there. There's obviously direct links between the climate drivers and the marine sectors. So rainfall directly affects the aquaculture in terms of, for instance, oysters. If you have a big rainfall event and you have a lot of freshwater wash up into a bay, it affects the oyster quality, so it affects the aquaculture industry. And the others also again speak for themselves. Then there's also feedback systems between all these. So emergent species, new things that come into the area might become valuable, might become commercial, or they might become these ones. And there's feedback systems between current and temperatures as well. So this is like what I mean by a spaghetti diagram. If you don't build it up, it just doesn't make any sense. But just to show you how you interpret this, as I said, temperature has a negative effect on retained species, has a positive effect on commercial fish species. So a negative and a positive is a negative. So change in temperature has a negative effect on commercial fishing. Temperature has a positive effect on emergent species, a positive effect on retained species has a positive effect on commercial fishing. A positive and positive and positive is positive. So in this case, this is how you explain qualitative models, and that's all it is. So we went to the community and we did the same thing. We built this model up again. And one of the interesting things that came out was that the communities didn't identify some of the variables and the climate change drivers. They didn't see some of the links. It didn't come up in the discussion, so we didn't prompt them to develop this model with us. So basically what we learned just from doing that exercise of building that model was that we realised that they had an incomplete understanding of the whole system, which then will help us shape our communication with the community about education and saying, look, there is actually a link between wind and currents, and wind has an effect on renewable energy as well. So just from doing the exercise with experts first and then with the community, taught us something about what their mental